Welcome back, class. This is lecture number 6 of organic chemistry, and in this lecture, we are going to discuss about the types of elimination reaction. As in our previous discussion, we had talked about the elimination and substitution reaction. There is a difference between the elimination and substitution reaction, and as we know that the nucleophilic substitution reactions occurs or controlled kinetically, and there is a two way for that, that is SN1 and SN2 type. So similarly, in the same pattern as we are going to talk about the elimination reaction, so the types of elimination reaction also deals with the same thing, like in SN1 and SN2. As we know that SN1 is the substitution nucleophile unimolecular and SN2 is the substitution nuclear bimolecular. So similarly here also we have two different types of reaction. One is the unimolecular and other one is the bimolecular. So let's start the discussion. The very first is E1 type. E1. Okay, so E1 is nothing but the unimolecular elimination. Unimolecular elimination. Okay, this is the page number 1. So what is the unimolecular elimination? So unimolecular biomolecules are the properties of chemical kinetics. Okay, so let's talk about the reaction first, and of course the mechanism we'll talk about. I'm not going to discuss it in very detail because this is same as SN1 and SN2. Nothing, there are a few changes that I will explain, but rest of the thing is similar. Okay, so I'm not going to discuss it in much detail. So here we have a alkyl halide, tertiary alkyl halide. We are talking about the E1. Okay, so E1 is H3C, H3C and H3C. Now this is a polar molecule, so it will be break in carbocation and Br negative. So this step which is the formation of carbocation is the RDS, rate determining step. Got it? Then in the second step, the cation, that means we have this cation, so we can C, H, H and H, H3C, CH3 positive charge and plus. This is the reagent. So this is a fast reaction. Okay, and we know that elimination is the elimination of a particular group. Okay, substitution is the substitution of a nucleophile by another nucleophile, but here one of the group will be eliminated. So this lone pair will abstract this proton, and as this will abstract this proton, what we'll get? We'll get CH2 here with double bond C, and then H3C CH3 plus H3O plus here. Okay, so this is the mechanism. And in elimination we had already discussed that the elimination means what? Elimination of a small molecule. Okay, one of the molecule will be eliminated permanently. So the chemical kinetics study shows that when we took the chemical kinetics studies, The kinetics, chemical kinetics shows that the rate of reaction is what is depending on the tertiary alkyl bromide only. Rate of reaction is depending on tertiary alkyl bromide only. So if it is depending on tertiary alkyl bromide only, that means it is a unimolecular reaction, because it depends only concentration of one of the reactant, and that is your CS3 whole thrice CBr. That means it is an unimolecular reaction. Okay, then there are several factors which are responsible for that. Sketch pen is not working now. Factor kinetics. So as we had already discussed it in detail in SN1, so I'm going to discuss in brief here only. See, as the number of R group is increases, rate of EN reaction will be increased. Okay, because the formation of cation, this cation is stable in case of tertiary, so number of R group increases, rate of EN will be increases. So first factor, as the number of R group increases, so as the rate of even reaction increases. Okay, so order will be R3CX, R2CHX, RCH2X. That means the tertiary, secondary and primary, just like SN1. No problem at all. In SN1 also the order is 3 to 1. Second factor, of course we required not a very strong base, because only we need to abstract this proton. Okay, so abstraction of proton, that means we need stronger base here, not weaker base, because we need to abstract the proton. Okay, so we required a stronger base. No, it's not like that, sorry. Weaker base, weaker base like H2O, ROH, this will favor even. Okay, third, better leaving group, better leaving group. So we know that what is the better leaving group: iodine, bromine, chlorine, fluorine. Okay, and the fourth one is polar protic solvent. Okay, so here, like in this case, we required a polar protic solvent which can stabilize, ionic intermediate. So all things are similar like SN1, nothing is different in this case also. So let's talk about the similarity. What are the differences SN1 and E1? See, SN1 and E1 is have exactly same mechanism up to first step. Okay, up to first step both have same mechanism, that means the formation of carbocation, only differ in the second step. That means what happened to the carbocation only differ in what happens to carbocation. Okay, so formation is of carbocation is similar in SN1 and SN2, but what happened with that carbocation, that is the problem. Okay, that is the difference actually, not problem, sorry. So like if we have CH3 CH3 and CH3, so this is a tertiary carbocation. Okay, this is a tertiary carbocation. Now if I have a nucleophile here, if I have a nucleophile here, so this nucleophile negative charge will what, it will attack to this carbocation. Okay, so here we have S1 SN1, so not what will get, will get NuCH3 CH3 and H3C. And in the second case, if you have a second case, same, like we have CH3 H3C CH3 plus, okay, carbocation, and now we have a base. Here we require a base, so this base will abstract proton, this will be abstract a proton, so abstraction of proton, that means the it will give E1. So here H2C double bond H3C and CH3. So similarity up to the formation of carbocation, but difference when the carbocation has a different mechanism, like one is addition of nucleophile and another one is the uh, elimination. Okay, okay, now moving ahead with the second page. As we know that the E1 reactions are often occur with competing SN reaction, because up to this level I think there is no difference until or unless you not have any we can have a second step. Okay, otherwise up to the first stage everything is similar as SN1. Okay, so many reactions SN1 is preferable compared to EA1. Okay, so because E1 reactions often occurs with competing SN1 reaction. Okay, that means E1 SN1 both are similar, there is no issue. So E1 reactions of alkyl halide are much less useful. E1 reactions of alkyl halide are much less useful than E2 because both has similar pattern. Okay, and the last one is the energy profile diagram. Energy profile diagram. Okay, so this also you know that what is the energy profile diagram. Let's draw this this is the reaction path, okay, time you can say that, and this is the energy. So what will happen, it is a two-step process, so the pattern will follow like this. So this are all we had discussed in SNL, so I'm not going it is in much detail. Okay, this is the reactant, sorry, base here, and here CH3 whole thrice C plus X minus. Here is the formation of carbocation, and then this is the intermediate, and this is the product. So CH3 whole twice C double bond CH2 HX. So this you all know that, I'm not going to discuss in two-stage process, so it has this one. Okay, and now let's talk about the second type of reaction, that is the E2. E2, that means the elimination bimolecular. So elimination bimolecular, here let's start with the reaction and the mechanism. Well, we have a carbon, then this carbon is have a different, but this is this SCH3 CH3, and then this is the CH3, this is the hydrogen, okay, and CH2 Br. Okay, so what happened here, this is base, this base will abstract this proton, and as this abstract this proton, this bond will be shift to here, and this will remove out. So we'll get H3C, sorry, H3C, H3C, carbon double bond, CH2, H2O, Br negative. Okay, so what is the mechanism here? Let's talk about the mechanism. In mechanism, just like SN2, the attack of base and the removal of leaving group is done simultaneously. So we have CH3 CH2 Br and H. Okay, this is the base, so this base will take here, and this goes to this side, this like this. So this is a slow step, and here CH3 and H, and this is OH. Okay, so this is the formation of a bond actually, CH2 and Br. So this stage is what you all know, that this is called transition state. This is transition state, the state where carbon is in different energy state. So here the attack of OH ion and the removal of bromide, the free radical, is done simultaneously. So it is a transition state, and then this Br will be removed, and what we'll get CH CH3, and here the double bond CH2 plus H2O and Br negative. Okay, again the same thing. The kinetics studies shows that the reaction is what? The reaction is of second order. Why? Because the rate of reaction is represented by KCH3 and CH3 CH CH3 CH2 CH2 Br and what? Base also. Okay, so both the reactants are important here. All bonds are break and form in a single step here. Okay, so this is one stage process, just like SN2, nothing else. Okay, so what are the factors? Let's discuss the factor also. So factor is again what the rate of reaction increases as the concentration of base will increase. Okay, that means here, because the base is also important in rate of reaction, so as the concentration of base increases, rate of reaction increases. So we required what? We required hence stronger base we required. Like in even it was weaker base, stronger base. What is stronger base? Like we have RO negative, OH. OH negative means this is KOH. Okay. Then again, the better the leaving group, better the leaving group, same. Better the leaving group, faster will be reaction. Faster will be reaction. Order is same. Here, like there in a even polar protic solvent required, here required polar aprotic solvent. Polar aprotic solvent increases rate of reaction. And the last thing, which is quite different, so this you need to understand. Third page, the last thing, this is different, so you need to understand this. The fourth one, as the number of R group increases, as the number of R group increases, okay, on the carbon, the rate of E2 increases. So here the order is 3 2 1, but in SN2 order is 1 2 3. This is you need to understand. In E2 order is 3 2 1. Okay, in E2 order is 3 2 1, less like in E1 also. In E1 is also, here the factor was carbocation. Here the factor was carbocation. And what factor here? Here we have to go for this base abstraction. So this base abstraction, that means a stronger base we required. Okay, so stronger base means what? Abstraction of proton. So abstraction of proton will be done if we have a number of alkyl group. We have a number of possibilities to abstract a proton, like if we have uh, C R R R. Okay, so here we have three. We have maximum possibility to abstract a proton. Okay, whereas in this case we have only two possibility to abstract a proton. In this case we have only one possibility to abstract the proton, so always the order will be this one. So this is the thing you need to understand. Energy profile diagram. So energy profile diagram, again, nothing is special in energy profile diagram also, because this is only this thing which is difference which I have mentioned here. So you should keep in mind the energy profile diagram. It is a single step process, so we require only one, like this. Okay, then this is what, this is CH3. You can take whole thrice CBr, and a base also here, CH3 whole thrice C plus and Br negative. So here the attack of OH is also occur, and this is not carbocation, this is, and here CH3 whole twice C double bond CH2. So this I think you all know that. I'm not going to discuss in detail. Time and energy. Okay, I think this you all know that, so I'm not discussing it in detail. And the last thing is the stereochemistry. This I missed. So stereochemistry is also very simple. This is not uh, stuff. Stereochemistry is just follow the Set-Jeff rule. Okay, that means both are regio selective and follow set Jeff rule. That means whatever is the reactant, that is input, that means that is uh, number of alkyl group. So in case of even if you have a compound like this CH3 and Br, and here is the water. Okay, so the product, if you go for two choices, one is this one and other one is this one, uh, this double bond. Okay, so this is the two choice. That means this carbon, okay, so this is a beta carbon and this is also beta carbon, this is a beta carbon, this is a beta carbon. So one can take any of these two. If you are taking this, and this will the product form, and if you are taking this one, and this product will form. So which one is major and which one is minor depends on the Set-Jeff rule. So which one is major, because here the number of alkyl group is, when here is the SES3. Okay, so this is the major, where in this case no alkyl group, so this is the minor. Okay, then E2. So if we have a choice Br, CH3, CS3 and CS3, so the base, again we have three choice. Okay, so you can if you go for, this is the beta carbon, this again beta carbon, you can take any of that, or you can this one. So what is the product here? Double bond CH3 CH2 CH3, and here CH3 CH3 CH3. So again this is the major and this one is the minor. Okay, so this is the stereochemistry of. So I think this is all about from E1 and E2 reactions. In this section we had talked about the different pattern of UNI2. So this is very much similar with SN1 SN2, so I'm not discussed in detail. Just watch my video of SN1 and SN2, and then go for this one. Okay, so this will help you out. And this is the only difference which I mentioned here, uh, in the pattern of carbocation here. Okay, so this you need to understand. Thank you so much. Thank you so much. Now, we have a question. We have a question for this video. The question is that only you have to complete the reaction. So the reaction is what here is the question mark, and then you have PBr2. The product is CH3 CH 3 Br, and then you have alkali KOH, then again the question mark, and then you have HBr HBr peroxide. This is the question mark. So you have three question mark, 1, 2 and 3. Only you have to complete this reaction and go for it. And if you are able to find the answer, please write your answer in the comment box, or you can WhatsApp also. If you like this video, please comment. Okay, and if you have any query, any doubt, anything you want to ask, just write in the comment box. Thank you so much.